Hello my dear students. Now I will explain Newton's third law. Newton's third law is saying that to every action there is an equal and opposite reaction. Means students, suppose there is a surface, you are hammering. Suppose there is a wall, you are pushing the wall. Means that is action. Means pushing by you on the wall. Remember this thing. By you on the wall, that is the action. Similarly, wall is also providing an equal and opposite force. The force you are giving, that is action. Similarly, by wall on you, okay, by the wall on you, a force, equal and opposite force is giving by that wall. That is called reaction. Now, everyday life you using this. Suppose some of your friend beat you. Similarly, equal and opposite you give that back, and so equal and opposite reaction is action. That is Newton's third law. Okay, so students, see, this is the statement. Now come to some introduction and explanation. See, Newton's first law tells us that bring a change in the state. Okay, bring the change in the state rest or in the state of motion an object force is needed. Means the qualitative idea. J, if object will be being a change in state, means in rest or in motion, whether it is in, some force is needed. Okay, that is a force produce a change in velocity. And second law is saying that, so second law tells us about the magnitude of acceleration produced by the force. Okay, F is equal to ma, mass into acceleration. So amount of acceleration produced when force is applied, that has said by the, explained by the second law. And change in momentum also, that is also can understand by the second law. But student, how this, what is the nature of that force, how it is acting, how the equal and opposite force act by that object, that is not explained by these two laws. So hence the third law is there, which will explain us the nature of force. Okay, means that here you can see that produced by force when applied on object. These two laws do not explain how force act on the object. Okay, so how force act on the object, that will explain by this. Their force is always exists in action reaction pair. Now once I am showing my note to easily understand, here you can see third law is that very easy, every action equal and opposite reaction. So force is exist in action reaction pair. So there is an example you can see. Suppose that is a table surface, there is a mass has kept on the table, so that mass is given force. Okay, if you say table A mass B, the below downward force will be F AB, means on A by B, which is writing in the first, that is on that, by the next, by this. Okay, so student remember this thing, that force, B is the book, A is the table. So book is giving some force on the table. Okay, that means force on A on the table by B is equal to, similarly according to the Newton's third law, table is applying some force on the book upper direction, that is force on book B by the table equal and opposite, means is equal to minus sign will come here. Understand, equal and opposite means that is equal to minus FBA. Means if you give move it left side, then it will plus FAB plus FBA is equal to 0. Means action and reaction force, they are exist in pair. Okay, equal and opposite, always equal and opposite, and their addition, that's why 0. That's why they are in neutral position. The book is not moving downwards, not moving upwards. Understand, action and reaction pair always. I hope this, that's all about the third law. If you understand up to this portion, complete, third law completed, understanding. So students, there is the book, action reaction pair, you understand. Now how the force is acting, you know, book is giving some force downwards, table is giving the force on the book. Students, you just remember this thing here, action reaction acts on different bodies. Action and reaction act on different bodies. Every time you remember this thing. Suppose that is the table surface, here is the book. So book is giving the force on table and table giving on the book. Okay, so different bodies. First book giving on table, book on table, the second time table on book. Understand? So different body is it, it's not on the same body. Okay, not on the same body. So action and reaction happens on the different body. Understand, students? Action and reaction acts on different body. If book will giving the force on the table, similarly table will give on the book. Remember, like this way, very important. So it shows that now we can understand that action and reaction act different body and equal and opposite same nature. Reaction same nature means equal and opposite. That's why student, that book is in stable condition. Suppose we are standing on the earth. Okay, suppose you stand on the earth. What the your weight is 76 kg, so that weight is your force you are giving to the by you on earth you are giving. Similarly, earth is also pushing upward on earth is maintaining that balance. Otherwise, so you sink. When you are walking on a muddy things, okay, there to we used to sink ourselves. Okay, in mud if you stand, we used to sink, some portion of our leg used to sink. Why? Because that earth is loosened, earth can't maintain your balance, so that much portion you will sink, up to which the balance will come. Understand? Up to which the action reaction pair will be equal, and if it is still not it is equal, you further going to sink. Understand? So that balance is coming by this third law is explaining the balance. Okay, action reaction pair is there. So force always exist in pair. Okay, pair means one action another reaction, that both are force. Okay, here the action is equal to mg. Here you can see, if I quantitatively say the name of the force acting, you can see one, you can say that mass giving its weight w is equal to mg. So the action force here is equal to mg and reaction force is n, means normal reaction. Normal reaction, you know, force which is acting perpendicularly on the object, on somebody, something perpendicularly force acting on it is called normal reaction. So action is here the actual action is mg, weight, action force, and reaction force is the normal reaction. Okay, so quantitatively these two forces balancing each other, normal reaction force and weight of the body is balancing each other. That's why that book is on that position. Okay, so student, this is totally this is all about the third law. There is nothing to understand. Some example we will learn, and here is a demonstration. Similar, just you see two spring attached. There is a hook. So when a hand is pulling it, what happens? First, this is attached on the wall. So if this is A, it's B and it's A. So how the force is acting? F B A means on B by A. That is the action which is close to the fixed wall. That will be there the action happens. Okay. So here it is attached with fixed wall. So we are pulling it. That means action you can see F on B. You check by yourself. Okay. F on B by A. This is action. Reaction is this spring also pulling this one. Okay, first we are considering this spring is pulling that this side. Now this spring also pulling this side. Okay, and that is FAB and the direction is this direction. Okay, and these both are equal opposite. That's why FAB is equal to minus FBA. Okay, this is all, and that too I have explained a book on the table. A book on the table too I already explained. Another example is it present in your book. So here you can see pushing a wall, moving a motion of a boat moving away the shore. Okay, there is the which one action? When boatman wants to move the boat away on the shore, he pulls the shore by a bamboo or with his oar. Okay, that is the action. And reaction means the shore pulls the boatman along with boat away with an equal and opposite force. That is the reaction. Okay, so with the he is pushing with the bamboo to the shore. Okay, suppose he is taking its boat to the water, so pushing the oar with the oar or bows or bamboo, that is the action. And similarly reaction, shore is pushing the boat towards the water. Okay, motion of boat on the water, that is also motion the boat moving away from the shore, that is also firing bullet. That is very important example you need to understand. Okay, see, recoil of gun, somewhere it will write like this way, recoil force on gun. Okay, so when just triggered the gun, okay, when force is exerted on this exerted on the bullet, that is action. So bullet is going out, that is force action, force on bullet by the gun. Similarly bullet will do some work on the gun. Okay, so just remember this is very important, by the gun on the bullet first. Okay, or on the bullet by the gun, same thing. Okay, on the first the force has given on the bullet by the gun, that is the action force. First the force which will come, that is action. Similarly the when the bullet is going out, it will relieve some it will apply some force equal and opposite on the gun, which is known as recoil on gun. Okay, reaction, or so the gun will move backside, that is action and reaction when firing happens. Okay, rocket motion, that is also you can see nozzle, it will release high pressure gas. Okay, force of gas is action, and force on the rocket happens by the atmosphere, that is the reaction force. By this way rocket is moving towards the sky. Okay, now motion on the ground also action reaction force. Otherwise we slippery, you know, in slippery surface reaction force is not proper, that's why we fall down. Okay, we are giving the action, but as the ground is slippery, here you can see in slippery road it is written slippery, so reaction force is not acting properly. Okay, so if it is rough surface, the reaction force will be good. Otherwise that reaction force is neutralized by the frictional force. Actually reaction force is the frictional force high, means reaction force will be more. But if there no friction force is there, reaction force is not will be weak, that's why we fall down. It is not balanced properly. Actually what we are working on the road, that is also action reaction. Okay, students, other example you read it, very easy. Next class I explain about gravitation.